Okay, so this is going to be a quick video on wind and current problems. So wind and current problems are done the same way. And what you have to understand about wind and current problems is that the wind and current in a situation is either going to add to the speed or it's going to take away from your speed. Think about if you've ever been walking in the water at the beach, and you're in the ocean and you're walking into the current, it's pushing against you, it's slowing you down. But if you stand in the water and don't move, 5 minutes later, you'll be further down the beach with the direction of the current as it pushes you along. So this is very similar to the problem in class kick, but it is a wind problem instead of current. So an airplane is flying into a headwind that travels 1,800 miles. Flying distance between the two cities in 3 hours and 36 minutes. So into the headwind, what that means is that I'm going against the wind, okay? All right, what else is important here is that we flew 1,800 miles in 3 hours and 36 minutes. On the return flight, the same distance is traveled in 3 hours. That's all I need to know about the return flight. Same distance, the time, and we know that we're going with the wind here because we did it faster. Find the ground speed of the plane and the speed of the wind, assuming they both remain constant and the ground speed is of the speed of the plane when there is no wind. So two things here is we're trying to find the speed of the plane, that's going to be our x, and we're trying to find the speed of the wind, that's going to be our y. So we're defining our variables, x is the speed of the plane, y is the speed of the wind. This is a distance, rate, and time problem. This is essentially round trip travel. So I'm traveling there for 1,800 miles and I'm traveling back for 1,800 miles. The only difference is my time has changed. So both of these situations, we're going to use the distance equals rate times time table. Both times, whether we went into the wind, which was against the wind, or with the wind, we traveled 1,800 miles, okay? The next thing we need to consider is our rates here. So our rate into the wind, that means we're going against the wind. That's our speed of the plane minus the speed of the wind because it's slowing us down. If we're going with the wind, that's the speed of the plane plus the speed of the wind because it's pushing us further and faster. All right, so for time, this is the trickiest part of this problem, honestly. So into the wind, against the wind took 3 hours and 36 minutes. So what we need to do is change this into a decimal, okay? So 36 out of 60 minutes is 6/10 of a minute, which is 6/10 as a decimal. So our time with the headwind is 3.6 hours. Our time into the headwind is 3.6 hours. Our time with the wind was only 3 hours. And this is how we're going to create our equations. So our equations are going to be 1,800 equals x minus y times 3, and 1,800 equals x plus y times 3. So to solve this, we would distribute to both of these, and we get 1,800 equals 3x minus 3y, and 1,800 equals 3x plus, typo there, 3.6x. See, little things like that will mess you up. 3.6x times 3 and 3.6y minus 3.6y, and 3x plus 3y. Now, we need to do elimination here. I will point out both of your y's have opposite signs for the coefficients. So what we're going to do is we're going to multiply by the other term. Just go ahead and cancel these out. So you're going to multiply this entire term by 3, and that includes every part of it, and this entire term by 3.6, and that includes every part of it, including the 1,800. Now, you are welcome to use a calculator on these. I totally understand that. So 1,800 times 3.6 is 6,480. All right. And then 3 times 3.6 is going to give me 10.8x. And then 3.6 times 3 is going to give me 10.8y. And then for my top equation, I have 3 times 1,800 is going to give me 5,400. 3 times 3.6 is going to give me 10.8x. And then 3 times negative 3.6 is going to give me negative 3.6y. So now this is not negative 10.8y. So now this is set up perfectly to do elimination. So we're going to make this a giant elimination problem. We're going to say this becomes 11,880. This is going to become 10.8 times 2, or 10.8 plus 10.8 is going to give me 21.6x. And the y's will eliminate, which is what we want. And again, I cannot stress this to you enough. Please use a calculator on this. So I'm going to do 11,880 divided by 21.6. And when I do this, I end up with the speed of the plane is going to be x, and that is going to be 550, and this is in miles per hour. So I found the speed of the plane, x, is 550 miles per hour, okay? So our plane is 550 miles per hour. All right, now to find the speed of the wind, we can plug that back in, and we can plug it into any one of these equations. I'm going to plug it back into this one because it's smaller numbers, it's got addition. So I have, and actually I'll do it when it's distributed. I have 1800 equals 3x plus 3y, and we're going to plug 550 into this. So 3 times 550 plus 3y equals 1800. And we're going to do 3 times 550 is going to give me 16,500. So 1,800 equals 16,500 plus 3y. We're going to subtract, and that's going to give me 150 equals 3y. And then we're going to divide by 3. Y equals 50. So the speed of the wind is 50 miles per hour. So one way the wind was adding 50 miles per hour, and the other way it was taking away 50 miles per hour. So I hope this helps with the wind and current problems. Again, the distance, rate, and time problems are going to be your best bet. Always figure out if it's round trip travel, same direction travel, opposite direction travel. That's going to make a huge difference. Hope this video helps, and